Welcome back. This is the next in an ongoing series of videos where I am learning about Rust. You can see these are the things that I have already learned. And I think the next thing to learn is about enums, and apparently there's something matching that goes along with it, and that's going to help us understand the underlying types better as well, I think. And then these are the things that I haven't yet gotten to, and we'll try and keep that list up to date as we go, as we find other things that we need to learn about. So I'm going to start, I'm reading the standard Rust programming language book by Steve Klabnik and Carol Nichols and Chris Kreiko. And we're going to do chapter 6 today, enums and pattern matching. I will pause the video when I will clip out the time when I'm reading, and then when there are examples, I'll pull them into Rust Rover and play with them to make sure that I really understand what they are telling me. So it starts out sounding like enums are enumerating its possible variants. That sounds like what enums are in most languages. But I have heard all sorts of things about how enums are weird and different in Rust, and so let's keep reading. Okay, so declaring an enum makes it a type, just like I'd expect, and then you can use that type as a parameter into a function. We declare variables to be of that type. I can pass in a string to make it so it has a variable in it. He didn't name that, and so I'm curious exactly how that plays out. So it doesn't seem to be named at all. It's calling it field 0. Can I do that? No. No field 0 and IP address. So if I've put it in that way, how do I get it back out? IPAddr v4 is a function call that takes a string argument and returns an instance of. Okay, they don't tell me how to get it out of there. I'm kind of pissed. Can I say no? I can't go get it that way. Oh, and now we're going to do it with even more things. Okay, this looks like unions in C, where an IP address holds one thing if it's a v4 and it holds a different thing if it's a v6. That's pretty cool. I still have to figure out how to get these things out of it, but I'm reading ahead in the hopes that I'll see that somewhere. Okay, in move, they named them. So that one, I would know, I think, how to get it out of it. I'm going to leave these on the screen because I'm still annoyed that I don't know how to get the string back out of it. If I say let message equal, but I want to make it a move so I can pull the thing out. Oh, I forget how to pass. Oh wait, those are curly brackets, not parentheses. Hang on a second. Quit has named fields like struct does. Write includes a single string. Change color has 3 I2 values. Okay, so this is very much like unions because each one of these things, you could do this as this set of structs, but the cool thing about making it an enum is one type can be any one of those, where if you do you'd have to know what kind of message you were getting to know, you'd have to know which one of these it could be. Okay, I'm not ready to go forward yet. I got to figure out how to get these things out of these. So if move is a struct with X and Y, let's go back to the syntax of how do I create a struct? Oh, that's what I thought I was doing. Oh, but I didn't have the curly brackets. Message colon move curly bracket X colon for Y colon. All right, and then with that one, I can say no field X in type message. Oh, maybe I have to do message as, I have to convince it to be a move message. No. Why are they never getting anything out of these? Ah. Ooh. Okay, so here they've made an enum. We didn't get to this yet, but they've made an enum that's a coin. And quarter can have an enum inside it. And then they print it out with a debug print. State colon question mark. Well, that would be the whole thing. Okay, that printed out the pieces. Where do I get the pieces? I want to get the pieces. No field X in message. Okay, all of these are using match to get stuff out of it. So maybe I just need to like chill my little self out and read further. So let's go back to where I was. Defining an enum. I can define the enum. I can put data in it. I can put different data in different, oh, what are they called? Enums are called, I think it was actually on the first page. Variants. Okay. So I can define it. It can have variants. I can put data in the variant, and I can actually do that a bunch of different ways. I can do no data. I can make it look like a struct. I can make it look like a single tuple, like a single thing. So like a tuple with one thing in it. So it's just a thing. Or I can give it a tuple. And the difference between a tuple and a struct is I named it. Okay, so that's how we can create them. And the advantage of doing an enum that for if you have something that has a bunch of mutually exclusive types, if you had made separate structs for them, then that variable would have to be of these particular types. But if I do it as an enum, I can declare the variable's type to be message, and then it can be any of these. So again, this feels very much like union in C, My guess is if we were to look at the memory that is allocated for a thing that is of type message, it would be enough memory for the biggest one of these. And then, but they all would lay in the same memory space. Oh, okay, now enums get cooler than unions, because now, like a struct, we can attach implementations to the enums. So we can essentially give them methods. So I can create a message, I can pass it in to a function by calling it like that. Okay. So that's like how to create enums. I don't think we've yet figured out how to get the data back out of them, but I'm going to try and calm down about that. So they're going to give us, as an example, the option enum. Oh, this is fun. I had optionals as a thing we needed to learn about. Now we're learning about them. Okay, so they've decided they've given you option, which is not a complicated enum, but they've given to you, and they've included it in the prelude. That means that it's in the stuff that's already imported, so you don't have to use the option prefix to see it. So when you have a function or a method that is returning something and it might not be able to give you what you want, then you can use an option. And the type of the enum is option, and it has two variants, none or some. And in that sum, you can pass back what you want to pass back. Okay, so let's play with this. I'm leaving that other code there because I still am waiting to get stuff out of it. So this returns an 8-bit integer with a 5 in it, and this returns an 8-bit integer with a 5 in it, but it's wrapped in an option. So there's a chance that y has nothing in it and a chance that it has something in it. So this plus is going to be mad because of the types don't match. You can't add an option to a thing. There must be a way to get unwrap. That should print out 10. Yeah. Okay. Oh, so option has a whole bunch of ways that you can get stuff out. Let's go look and see what kinds of things they are. Oh, so when I said unwrap, just gives me the thing. Oh, but this function may panic, so it is generally discouraged. Panics are meant for unrecoverable errors. Instead, prefer to use the pattern matching and handle the none case explicitly, or call unwrap or else, unwrap or default. In functions returning option, you can use the try operator. Oh, cool. Unwrap or lets you whatever your option is. So in this case, this is the option. And when you unwrap it, it's okay. So you get a car back. In this case, this is the option. And when you try to unwrap it, it's not okay because there's nothing to unwrap. And so that would give you this as the thing in the unwrap or would match this. Unwrap or else. Okay, I think we could do a whole, let's go play with the weird things you can do with options. For now, I totally understand why my unwrap was bad, because if this had been none, this would have panicked. So if I had, instead of this, I had said, let y equal none, and you're going to have to say option : : we have to tell it what type it should. That's a funny colon. We have to tell it what type it should be, because from the none, it can infer option, but it can't infer the generic type. And so it needs us to tell it the generic type. And if I run this, it'll panic. So you can see it panicked at line 25, where it did the unwrap. I did an unwrap on a none, and that made it very mad. So unwrap or 13. If you get none, you default to 13, then we ought to print out 18. Oh, that is slick. We certainly, okay, we know what an option is, but we're only going to do intro to options today. My guess is there's ways to get data out of options that we ought to study better. Okay, where was I? Here I was. Okay, so that was options. The match control flow construct. Okay, so this tells me that we're going to get intro to match in this one. And we're going to need to do match tails again. But at least this will give us a start of match. All right, so this looks to me sort of like matches like switch. This function, well, let's go look at this. This function is going to this function takes a thing that is one of these enums, so the type is enum, and returns an unsigned 8-bit integer. This looks like match coin. It's going to look at coin. Is it a penny? Is it a nickel? Is it a dime? Is it a quarter? And this match statement will evaluate to whichever one of these got picked. And that'll be what gets returned. And then X should have in it a 1. And it does. Okay, so match looks like switch. And but instead of like doing things in each case, it's just giving the value that the statement should evaluate to. So the parameter to match is a type, not a value. Okay, so it promises to do the sections in order, and the first one that matches is the match that is going to happen. The code associated with each arm is an expression. Oh, and so you can put other code in there as well. So you can think of this like it's a teeny tiny function that evaluates to the last, the match will evaluate to the last thing that you put in the arm. Okay. Okay, so now we're back, we're going to look at this one. State quarter from Alaska. Okay. That's now pulling out what's in the quarter, and it's doing it by matching this. So it's saying when we pass in our coin that has as its parameter the Alaska enum, when it comes in here, it'll match that to the state that's stored in it. Okay, let's make it have another thing in it. The year that it became. And now I'm going to need to do this one like the struct kind. U.S. state, colon, no, state, colon, U.S. state by 2 by 16. 16 enough? Oh, backwards. It's funny how it takes you like forever to get reused to something. Then if I made this state Y, expected the tuple. Okay, I admit it. My husband wanted lunch, so I took a break. But I think I have to name this what it was named there. So I had to make this match that. And then I can pull them out using this. And then I think... but wait, not a value. Oh, because I didn't give this one a year. Oh, you couldn't have Alaska back then. I don't know if Alaska was in 2024 or not. Doesn't matter. Could not find coin, colon, colon, quarter with a state and a year. Oh, because I made it the struct kind, not the enum kind. What did the enum kind look like again? Do it with that. Oh yeah, oh yeah, now we got it. With the enum type, I can do this. There we go. State, whatever. And I can pass that into values and sets. Okay, I'm sure that I could do this with the struct kind as well. I would just have to figure out how to call how to create one with the struct kind. But I want to, and so now I can get things out of it if I'm inside a match statement. I know how to get stuff out of it. I'm still wondering how to get all right, I'm going to stick a pin in that again. At this point, I can pull stuff out of it if I'm in a match statement. I can't pull stuff out in general, but maybe we'll learn that. Let's just keep going here. Matches are exhaustive. Oh, you have to put all of the cases in a match, so there's no like default. You have to put them all there. I like that. Let's go look at this because it has this word other in it. So I make it in a dice roll that is a 9, which it decides is an unsigned 8-bit integer. If it's a 3, I add a fancy hat. If it's 7, I remove the fancy hat. Otherwise, I do a move player others. So let's I'm going to leave all that. So now when I get down to here, I'm going to get rid of that because we're finished with that. When I get down to here, the 9 should do other, which would move player that amount. So I should see move player 9. Move player 9. If I pass in a 3, I'm adding a fancy hat. And if I pass in a 7, I'm removing the fancy hat. And just to make sure it's not only things after, if I pass in a 5, I think I'm going to get move player. I did. Okay, so other is if it's not in the list, do the other thing. And then you don't have to list them all. So that's sort of like default in a switch statement. Okay, so they're saying instead of other, if I didn't want to use the value, I could use underscore. Yeah. Okay, so in this other one, the nice thing about the other one was that put the value that I was doing the match on into a variable named other, and that let me pass it in. You know, that let me use it. If I don't want to use it, I can just put an underscore to mean everything else. And if we want nothing to happen, we can put an empty tuple there. The match will evaluate to nothing. Okay. All right, so that appears to be what we needed to know about the match statement. So they're saying we can so we let config max be a sum thing, and then we let this other sum thing equal config max. That's how we pulled it out. Ah ha 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 ha. So if I said let refutable pattern. Oh, okay. It's mad because I know it's a quarter and you know it's a quarter, but the compiler says quarter technically could be any of the other coins because quarter's type is coin. If I declare it to be a coin, quarter, can't find value quarter. Well, I'm trying to put this before this with a space, with a colon, expected type, but found a thing. All right, we're getting closer, but I still need this to be in a match so that it knows that it's a quarter. So we're not there yet, but I'm getting, oh, I can do the if let thing. Do what you're, if let quarter equal that. Yes. And this would be S, Y. If let, oh, then this has to go inside that because you can only do that if you can do that. US state does not implement display. Oh, how am I? Oh, colon. Aha. Okay. So this if let magic is how we get things out of these. If you don't want it, if you're not in a match where you have all of the cases, if you just know that it is something or you want to do something only if it is something, I can say if let. So what I've done is in line 49, I made a variable whose type is coin. It happens to hold a quarter from Alaska in the year 30, which is a strange year, I'll give you. Then I can use this if let coin quarter sy equal quarter. So the magic, the thing that's happening in these assignment statements is it's like pattern matching the whole set of things. So it knows that quarter is a coin quarter Alaska 30. And so when I make this equal to that, it puts the Alaska in X or S and the 30 in Y, and now I can print them out. So this if let is the magic for how you get something out. And we should pay attention to the fact that that assignment statement is not just making one quarter equal another quarter. It's letting the variables inside here, S and Y, it's pattern matching those. So, it might be clearer if I showed it to you this way. So it's lining all of those things up, and it's knowing that the state is Alaska and putting that in S, and the year is 30 and putting that in Y, all in one assignment statement. That's pretty slick. Oh, and we can put an else on that. Okay. Let's play with states the way they're playing with states. So I'm adding to this state enum this existed in function. And then I'm doing maybe I don't need, I think they're just saying this works, but look at all of the stuff that's in that if statement. My guess is they're going to do that with a match statement and it's going to look much prettier. Okay, this is just how to write better if statements. I mean, this is like the same kind of reasoning as instead of nesting the if statements, let's not nest the if statements because we're going to return the none. That's just better if statement code, which I like. And it's even better if you pull the coin out whole, pull the state out of the coin with the first let statement. Let else. So we had up here, we had let, and there was an if let inside there. Let something else do something. Okay, so what I think is happening, what is happening here? So this is, we did the let the quarter equal coin. If that was false, we returned none. If it was true, this evaluated to the state, which we stored into our own variable named state. So this is the state that got pulled out of the quarter. We put that in our own variable named state. And then we used that to decide if the state existed or not. But there is also let else. Instead of if let, there is let else. So let else is going to evaluate this if it's able to match it. So if you have passed in a quarter, it will, that will evaluate to not false, like it won't have a problem. So it won't do the else part. And state will have been pulled out, and then we can use it to decide what our output is. So the only thing that's weird to me is why did I have to do this? Oh, because this was saying I needed the if and the else parts. If I coded it with an if and an else, then this evaluates to the state. I have to save that someplace. I'm not sure that I'm gonna, come here a minute. Instead of making this a function, I'm just gonna let, oh no, I'll do it. Why not? Make it a function. And this needs a year in my, oh, they've used year for something different. Let me pick up there. So they added this to the state. Yeah. Oh, okay. That's where the year is. Okay. So quarter, I have a different year in mine. That's like the year the quarter happened, not the year the state happened. Not done. And put quarter back to their way of quarter. There we go. And then this doesn't need this anymore. Okay. So this is their code. And I have to take out my here stuff. Function instance is never used. Who cares? Alabama is pretty old for America. Okay, so then I did all of that to show that their code worked. What happens if I get rid of this? Okay, so the scope of this variable must just be this let statement. Which doesn't. So we have to assign it to another one. Wouldn't it be nice if it would highlight the scope? Oh, condition binding. And this one. Yeah, okay. So essentially that's what it is. This state exists while you're in this if let statement. I want to use it down here, so I have to also put it in a let statement, and then this variable is not this variable. It's a different one with a different scope. And then they make it even prettier by using this else idea. So if I do this, now state, because it's in a let statement, not an if let statement, state's scope is the function. So the coin comes in, gets matched, its state gets put into state because it is a quarter. If it was not a quarter, then we would have returned the none kind of option instead of down here where we're returning the some kind of option, because you can only do this for things that are quarters. Okay, that was fascinating. So these kinds of things, it feels like, you know, I've learned a bunch of facts about enums and matching and if let statements. But at some point I have to actually like do something real with this. I found somebody implementing linked lists in Rust using an enum. And the cool thing about, you know, like I never would have thought of this as an enum thing, but in a linked list, a node can either point to another node or it can point to nothing. And so they've made two kinds of nodes, essentially. A list is either a cons or a nil. And this is a tuple that basically has a unsigned integer and a reference to another one of these enums. So it's doing that thing that we learned about before, where box is putting something out on the heap and giving us a pointer to it. So this line 5 is essentially a node that has an integer and a pointer to another node. And if that, so that's one kind of node. The other kind of node is the nil node, and that is when there's a nil. And so when you're going to create a new list, you get the null node. Prepend is going to put your new thing before, and it's going to make a node that has your new thing and a pointer to your old thing. So that when you start to do things like what is the length, then we're looking at, this is essentially, if you have a node, it's one more than the length of the tail, and that's, we're pulling that out of the box thing there. And if it's nil, it's 0. So it's recursively doing it, but instead of with an if else thing, it's doing with a match. And the same thing with its stringify. It's just concatenating them together. So that looks really cool. I think at this point, I need to stop learning more stuff and I need to build something. So for the next video, I'm going to figure out some data structure that I can build. I'm thinking a binary search tree, because it would be sort of like this list thing that I saw, but it would be different because there would be multiple places you could go and ordering matters. And, you know, I think there would be some challenges in that, but I'm going to try to do it using Rusty sorts of things instead of the way that I would normally build. But I'll think about binary search tree before I commit to that. See you next time.